Okay friends, welcome to part 4 of projectile motions. We're going to look at the horizontal range. So we need to look at the horizontal range in this discussion. So we have the y-axis, the x-axis, theta, the whole trajectory, theta, the angle of projection, and the speed at which the projectile is moving at. And what we're required to find is the horizontal range. Now, horizontal range just simply gives us the distance from the point of projection up to where the trajectory ends, and that is on the horizontal axis. So the distance on the horizontal axis from the point of projection to where the trajectory ends. So that's what gives us the range. Now, if you remember that the formula for displacement using kinematics is presented in this manner. Now, since we're looking at the x-axis, s will be substituted with x. Then we're going to look at the initial velocity component, which is ux, then multiplied by t, which is the time of flight we're going to use it, then plus half multiplied by the acceleration in the x-axis times the time of flight squared. Now, if you remember, acceleration on the x is equals to 0. Thus, we just get x to be equal to the component times t. Okay, now initial component of velocity is equal to the speed times cos of the angle theta. Now, since we're looking at the range, I'll replace x with r, then I'll say subscript of x, which is equal to, now I'm going to put u cos theta there. Now, while there's t, I'll put the formula for the time of flight, which is 2 u sine theta over g. Okay, so this is what we got in the previous video. So upon multiplying, we'll have our range, horizontal range, to be equal to u multiply with g. I'm going to get u squared. So they are going to get u squared. Then I multiply cos theta times sine theta times 2 to be the same as 2 sine theta cos theta. So this will be u squared. Then we must have times 2 sine theta cos theta. Then we're simply going to divide everything by g. Now, if you did trigonometric identities, you can agree with me that 2 sine theta cos theta is an identity we know, of which what you substitute there is simply sine 2 times of the angle theta. So this is a double angle identity for the sine ratio or sine function. So this is equals to sine 2 theta. So that's what we're going to substitute there. Hence, we're going to get our range to be equal to u squared, then sine 2, over g times sine 2 theta, which will still be presented as our range to be equal to u squared sine 2 theta over g. So this is how you obtain the range, which is the horizontal range, the distance from the point of projection to where the trajectory ends, that is on the horizontal axis. Now, in a case where you're taught to find the maximum range, you need to note that maximum range is obtained where angle of projection is equals to 45 degrees. So we get to have the maximum range at theta equal to 45 degrees, like that. So upon substitution, you get that our range, which is the maximum range, will be nothing but u squared, then sine 2 times the angle, which is 45 in this case, then divided by g. Okay, so this will give me the maximum range to be equal to u squared. Then we multiply 2 times 45 to give us sine 90 over g. Now, if you punch in the calculator, get that sine 90 is the same as 1. Hence, we get the maximum range to be equal to u squared over g. So this is how you obtain the maximum range in a case where you are required to do so.